Okay, so this type of problem is called can be solved using the method of initial rates. So what this is well, first we can write a rate law. So you can say that rate is equal to the reactance. Well, first of all, K constant, and then reactance A, and then B, and then they both have what is it, exponents that we have to figure out using this data. So how are we going to do that? So let's say we want to find the order of A. If we want to find the order of A, we look for two sets of data that stay the same, meaning we want B to stay the same so we can see that when A changes, we'll know what happens to the rate and how A affects the rate. So let's do it. So for B, 1.5, right? It stays the same. 1.5 and 1.5, the first and second for B. So B's not changing. But then for this one, for A, it actually does change. It doubles 1.5 to 3, right? So right here, it just doubles. So the concentration of B is exactly the same, but A doubles, right? So then we look at rate. So 3.2 to 6.4. Make sure you look out for the exponent of this to make sure that they're exactly the same. But you can see that 3.2 doubles too. So 3.2 doubles to 6.40. So B's held constant, A's doubled, and the rate of the first one to the second one has doubled. So what does that mean? If the concentration doubles and the rate doubles, that means it's an order of 1. So now we want the order of B. So we want to hold A constant, so 1.5 from 1.5, so A's constant, and then we look at this, 1.5 and 2.5. Okay, so A's constant, B's changing, and then we look at rate. Well, we see that the rate actually stays the same. So A's constant, B actually changed the constant. This is a 2.5. B's actually changed, but rate, it's done nothing for rate. If nothing occurs, then it's an order of 0. If it's an order of 0, it actually doesn't affect it at all, and we can take it out of the rate law. So the final rate law will be rate equals Ka. The order will be 1. Because you add up all the exponents in a rate law, which will just be 1, and the order will be 1. So let's say if they wanted us to find K, okay, we can do that because we're actually given data. So all we have to do is just plug it in. So we have rate, which is in the correct units. So let's take the first experiment, let's do that, and plug in rate 3.2 times 10 to the negative 1 equals K, and the concentration of A, which is 1.5, and then your answer will turn out to be K will equal 0.213 over 1 over S. And that will be your rate constant for this problem.